Every day in space is slowly destroying your body. Imagine waking up tomorrow, 400 kilometers above Earth. You're floating, weightless, disoriented. You're not in your bed anymore. You're in a metal tube, moving at 28,000 kilometers per hour. And already, within hours, your body is starting to fall apart. Your face begins to swell. Fluid that gravity has been pulling to your legs your entire life rushes to your head. Your sinuses fill with fluid. You can't smell anything. Your sense of taste disappears. The food that was carefully prepared to be palatable in space suddenly tastes like cardboard. Your muscles start disappearing. Without gravity, they don't need to work, so they shrink. Your bones begin dissolving. Your body, so efficient that it refuses to waste resources on things you don't need, stops building bone. It starts breaking it down, and if you stay long enough, some of the damage will never heal. This is not science fiction. This is what happens to every single human being who goes to space. Every day you spend in space is slowly destroying your body. Not metaphorically, not eventually. Right now, in real time, space is breaking you down. You've seen the videos, the smiling astronauts floating in the International Space Station, the wonder in their eyes as they look at Earth through the cupola, the joy of weightlessness, the thrill of being in space. It looks like the greatest adventure humanity has ever created. And it is, but it's also something else, something darker, something NASA doesn't put in the recruitment videos. Because behind that smile, behind that floating body, there's a war going on. A war between the human body and the environment it was never designed to inhabit. And the body is losing. Every astronaut knows this. They've all been briefed. They've all read the studies. They've all seen what happens to the ones who came before. But nothing can truly prepare you for what it feels like when your own body starts to betray you. Every day in space is slowly destroying your body. Your first day in space is not what you expect. You've trained for years. You've been in simulators. You've experienced parabolic flights that give you 20 seconds of weightlessness. You thought you knew what to expect. You didn't. Within minutes of reaching orbit, your body realizes something is terribly wrong. The fluid that gravity has been pulling to your lower body your entire life is suddenly free. It rushes to your head. Your face swells. Your legs shrink. You look like you've aged 10 years in 10 minutes. Your sinuses fill with fluid. You can't breathe properly. You can't smell anything. Your sense of taste disappears. The food that was carefully prepared to be palatable in space suddenly tastes like cardboard. Your inner ears, the balance system that's been working perfectly for decades, goes haywire. Your brain receives conflicting signals. Your eyes say you're stationary. Your inner ear says you're spinning. The result is space adaptation syndrome, motion sickness, nausea, vomiting. In the first 24 hours, about half of all astronauts get sick. But that's just the beginning, because even as you're trying not to throw up, your body is already starting to dismantle itself. Every day in space is slowly destroying your body. 1 month in space, 30 days. It sounds like nothing. A vacation, a sabbatical. But in that 30 days, your body has undergone changes that would take years on Earth. Your bones are eroding. In space, your body doesn't need the dense structural support it needs on Earth, so it stops building bone, and it starts breaking it down. Astronauts lose about 1 to 1.5% of their bone mineral density per month. That's more than 10 times the rate of osteoporosis on Earth. In 1 month, you've lost more bone than most people lose in a decade. Your muscles are wasting away. Without gravity to work against, your muscles don't need to work as hard. They shrink, they weaken, they lose mass. Astronauts can lose up to 20% of their muscle mass on long-duration missions. Your heart, the strongest muscle in your body, is also shrinking. It doesn't need to pump as hard in microgravity. It gets smaller. It gets weaker. When you come back to Earth, your heart struggles to pump blood to your brain. You feel dizzy. You feel faint. You feel like you're dying. And then there's your spine. Your vertebrae are compressed on Earth by gravity. In space, they expand. You get taller, up to 2 inches taller, but that expansion also causes back pain, herniated discs, pinched nerves. One astronaut reported that his entire back ached for weeks. Every day in space is slowly destroying your body. Now let me tell you about 2 astronauts, Scott Kelly and Frank Rubio. In 2015, Scott Kelly did something no American astronaut had ever done before. He spent 340 consecutive days on the International Space Station. nearly a full year in microgravity. Floating, working, sleeping, eating, living in a tin, can hurtling through space at 28,000 kilometers per hour. But Scott wasn't just any astronaut. He had an identical twin brother named Mark, also an astronaut, also genetically identical, also the perfect control subject for the most ambitious human biology experiment ever attempted. NASA called it the twin study, and when Scott came back to Earth, the scientists went to work. They compared his body to Mark's. They looked for every change, every difference, every anomaly that spaceflight had caused. Then there's Frank Rubio. In 2023, he returned to Earth after spending 371 consecutive days in space. That's longer than Scott Kelly. He holds the record for the longest single spaceflight by an American astronaut. When he came back, he described how difficult it was to adjust. He had to be carried out of the capsule. He couldn't walk. He couldn't stand. His body had to relearn what gravity felt like. What they found with Scott Kelly was disturbing. Scott came back taller because his spine had expanded in microgravity. He lost muscle mass. His eyeballs changed shape, and his vision was permanently altered. He was 5 milliseconds younger than his brother due to time dilation. But those were just the surface changes. The real story was happening inside his cells. Every day in space is slowly destroying your body. When the results of the twin study were announced, the media went crazy. Scott Kelly's DNA changed by 7% in space. He's no longer identical to his twin space. Mutated his genes, those headlines were wrong. They misunderstood the science, but they were closer to the truth than anyone wanted to admit. Because while Scott's DNA didn't mutate, something else did change. Something equally profound. It's called gene expression. Not the genetic code itself, but which genes are turned on and off. Think of it this way. Your genome is like a massive instruction manual. Every cell has the same manual, but different cells read different chapters. That's gene expression. And in space, the manual gets rewritten. NASA researchers found that while Scott was in orbit, thousands of his genes changed their expression levels. His body was adapting to the extreme environment, responding to radiation, microgravity, stress, and isolation. Most of those changes reversed when he came back to Earth. Within 6 months, about 93% of his genes had returned to normal, but 7% didn't. That's right, even 6 months after landing. Around 7% of Scott's genes were still expressing themselves differently than they did before he went to space. Scientists identified 811 genes across different types of cells that never returned to their baseline levels. These weren't just random genes. They were the ones that controlled 2 critical processes: immune system function and DNA repair. Think about what that means. Scott Kelly's immune system, even after 6 months back on Earth, was still operating in a space mode. His body's ability to repair damage from radiation and other stressors was permanently altered. The effects of space were still written into his cells. But it gets weirder. During his year in space, Scott's telomers grew longer. Telomers are the protective caps at the ends of our chromosomes. They're like the plastic tips on shoelaces. They prevent the DNA from fraying. And as we age, they naturally get shorter. Short telomers are linked to aging, disease, and early death. But in space, Scott's telomers didn't shorten. They lengthened. They got longer than his brother's. They got longer than they'd ever been in his life. It looked like space was actually slowing down his cellular aging. Scientists were baffled. But then, something even stranger happened. When Scott returned to Earth, his telomers didn't just stop growing. They shrank fast. Within months, they'd returned to their pre-flight lengths, and some even got shorter than before. It was like watching a biological bungee cord. Snap, stretch, snap back. Except it didn't snap back all the way. The scientists still don't fully understand what caused this. Was it the radiation, the microgravity, the stress, the diet? They're still trying to figure it out. And that's what makes it so unsettling. We're sending people into space, and we don't even understand how it changes them at the cellular level. Every day in space is slowly destroying your body. But the DNA changes are just the beginning. The real damage might be happening in your brain. When you're in microgravity, your brain floats. That's not a metaphor. Your brain literally shifts upward inside your skull. It pushes against the top of your cranium. The cerebrospinal fluid that cushions your brain redistributes. The optic nerve is compressed. This causes spaceflight-associated neuroocular syndrome, or SANS. The structure of the eyes and brain change in microgravity. The optic disc swells. The eyeballs flatten. The vision changes. Some astronauts have never fully recovered their eyesight. But it's not just your eyes. Your entire brain is affected. The white matter, the network of connections that allows different parts of your brain to communicate, shows changes after long-duration spaceflight. The gray matter shrinks and then re-expands after returning to Earth. And then there's the cognitive decline. Tests on Scott Kelly showed that his thinking speed and decision-making accuracy decreased in space. And even after returning to Earth and adapting back, those abilities didn't fully recover. This isn't just Scott. Symptoms are common among crew members. The space environment affects the brain in ways we still don't understand. Radiation may be causing brain damage. It may be contributing to the onset of diseases like Alzheimer's, and the effects could be cumulative. Every mission, every extended stay, could compound the damage. We have no idea what happens to someone who spends years in space, because we've never sent anyone that long, until we send someone to Mars. Every day in space is slowly destroying your body. Now we get to the biggest threat, the one NASA is most worried about, the one that could end the dream of Mars. Radiation, even on the ISS, which is partially shielded by Earth's magnetic field. Astronauts receive about 10 times the annual radiation dose of someone on Earth. A mission to Mars would be exponentially worse. Mars is about 225 million kilometers away on average. The journey would take about 6 to 9 months each way. That's 18 months of exposure to deep space radiation. Cosmic rays, solar flares, galactic cosmic radiation. This radiation damages DNA. It breaks strands. It causes mutations. It increases cancer risk. It can cause cognitive decline. It's the silent killer of deep space exploration. NASA has measured the radiation levels. They've done the calculations. They've estimated that the radiation dose for a Mars mission could be as high as 1 sievert. For comparison, the average annual dose on Earth is about 2 to 3 millisieverts. 1 sievert is more than 300 times the annual dose. And we don't know what that will do to the human body. We've never exposed anyone to that much radiation. We don't have good countermeasures. We don't have effective shielding. The radiation is constant. It's everywhere. It penetrates everything. Even in a spacecraft, even behind shielding, you're still being exposed. And the longer you're in space, the higher your risk. This is the problem that keeps NASA scientists up at night. The problem they don't talk about in public. The problem that could kill the Mars dream. Every day in space is slowly destroying your body. Let's go further. Let's imagine something truly terrifying. What if you stayed in space for 10 years? Right now, the record for the longest continuous spaceflight is 437 days. That's held by Russian cosmonaut Valery Polyakov, and even he suffered serious health effects. But 10 years, that's 3,650 days, nearly 4 times longer than the current record. It's not a mission anymore. It's a life sentence. What would happen to your body? Your bones would be ravaged. Even with rigorous exercise, you'd lose at least half your bone density. You'd be at constant risk of fractures. Just standing up on Earth could break your hip. Your muscles would wither. Your heart would shrink. Your immune system would be compromised. The dormant viruses in your body, the ones you've been carrying since childhood, would wake up. Herpes, shingles, you'd be sick all the time. Your vision would be permanently damaged. The optic nerve would be compressed. The eyeballs would be flattened. You'd need glasses for the rest of your life. Maybe not even glasses would help. Your brain would change. The cognitive decline would be severe. You'd have trouble concentrating. You'd have trouble remembering. You'd have trouble making decisions. The radiation would have accumulated to dangerous levels. Your cancer risk would be off the charts. You'd be lucky to survive the next decade. And when you came back to Earth, you'd need months of rehabilitation. You'd need to learn to walk again. You'd need to rebuild your muscles. You'd need to cope with the psychological trauma of being away from Earth for a decade. You wouldn't just be changed by the experience. You'd be changed by the environment. Permanently, irrevocably, every day in space is slowly destroying your body. But here's the question that changes everything. Can we ever evolve to live in space? Not just survive, not just cope, actually adapt, evolve, become a species that belongs out there? The answer is, maybe. It's not science fiction. It's evolution. And evolution is patient. Over thousands of generations, humans living in space could develop physical adaptations. We're already seeing hints of this. The changes that happen in astronauts, the bone loss, the muscle atrophy, the fluid shifts are actually adaptive responses. Your body is trying to adjust to the new environment. It's trying to become more efficient in microgravity. The problem is, we don't stay in space long enough for those changes to become permanent. We come back to Earth, and our bodies have to readjust. It's the worst of both worlds. You never fully adapt to space because you're not there long enough. And you never fully recover on Earth because your body was changed. But what if we stayed? What if we built permanent colonies on the Moon and Mars? What if generations of humans were born, lived, and died in reduced gravity? Over time, natural selection would favor those who are better adapted. Longer limbs, weaker bones, different cardiovascular systems, eyes that aren't affected by fluid shifts, maybe even changes in the brain. We would become a new species, Homo sapiens spatium, space humans, and then there's genetic engineering. We already have the tools. CRISPR and other gene editing technologies could potentially help us adapt. We could edit the genes that control bone density. We could edit the genes that affect radiation resistance. We could edit the genes that influence immune function. It's controversial, it's ethically complex, but it's possible. We could design ourselves to live in space. The future of humanity in space isn't just about building bigger rockets. It's about changing the people inside them. It's about evolving. It's about becoming something new, something that belongs out there, something that can thrive in the void. Every day in space is slowly destroying your body. But maybe, just maybe, that destruction is also the beginning of something else. Something beautiful, something unprecedented, something that could make us truly a multiplanetary species. So where does that leave us? We want to go to Mars. We want to build bases on the Moon. We want to become a multiplanetary species. We want to explore the stars. But our bodies were built for Earth. We evolved in gravity. We evolved under the protection of Earth's magnetic field. We evolved with the rhythms of day and night, of seasons and cycles. Space is not just another environment. It's an entirely different way of existing. And our bodies are not ready for it. But that doesn't mean we give up. It means we adapt. It means we innovate. We're developing better countermeasures for bone loss and muscle atrophy. We're designing artificial gravity systems that could spin spacecraft to create centrifugal force. We're developing better radiation shielding. We're studying the genetics of astronauts to understand who might be more resilient. We're learning. We're improving. We're getting better at protecting our astronauts. But we need to be honest about the cost. We need to be honest about what we're asking of the people who volunteer to explore space. We need to be honest about the long-term consequences. Because if we want to go to Mars, if we want to become a multiplanetary species, we need to figure out how to keep our astronauts alive. Not just for the mission, for the rest of their lives. And that's the part that NASA doesn't tell you. The part that's hidden in the scientific papers and the medical reports. Space is not just an adventure. It's a sacrifice that astronauts are willing to make. But we owe it to them to understand the cost. Every day in space is slowly destroying your body. Space doesn't hate us. It simply doesn't care. It's not malevolent. It's not hostile. It's just indifferent. It doesn't care that we're fragile. It doesn't care that we evolved in gravity. It doesn't care that our bones dissolve and our muscles waste away. It's just physics, just chemistry, just the cold, uncaring laws of the universe. Every astronaut who leaves Earth is fighting millions of years of human evolution. They're fighting the very biology that made us human. They're fighting against the gravity that shaped our bones, our muscles, our hearts, our brains. They're fighting against the magnetic field that protected us from radiation. They're fighting against the atmosphere that shielded us from cosmic rays. And every mission teaches us one simple truth. The greatest challenge of exploring space isn't building bigger rockets. It's not developing better propulsion systems. It's not designing more efficient life support. All of that is hard, but it's solvable. It's engineering. It's physics. The greatest challenge is keeping the human body alive, in a place it was never designed to be. In a place that is slowly, methodically, relentlessly breaking it down, day by day, hour by hour, second by second. Every day in space is slowly destroying your body. But we keep going. We keep sending people up there. We keep pushing the boundaries. We keep exploring. Because that's what we do. That's who we are. We are explorers. We are pioneers. We are the ones who refuse to accept limits. And maybe that's the most human thing of all. To go somewhere that is destroying you. And to stay there anyway. Because it's worth it. Because the knowledge is worth it. Because the future is worth it. The next time you look up at the night sky and dream of going to space, remember Scott Kelly. Remember Frank Rubio. Remember the 811 genes that never returned to normal. Remember the telomeres that stretched and snapped. Remember the cognitive decline that persisted. Remember the astronauts who gave parts of themselves to the cosmos. Every day in space is slowly destroying your body. But that's not a warning. It's a recognition of reality. Because the truth is, we're going to space. We're going to Mars. We're going to explore the cosmos. And we're going to take our fragile human bodies with us. We just need to be prepared for what that means. We need to be prepared to protect our astronauts from the environment they are entering. We need to be prepared to care for them when they return. We need to be prepared for the long-term consequences of leaving Earth behind. Because once you leave, you don't really come back. Part of you stays in space, in your genes, in your cells, in your very being. And that's the truth that NASA never told you.